the weightage of recursive and iterative function topic in CAT examination, right? Why we need to concentrate on this topic? Unless you understand why, what, when, where and how, probably people will not understand. Unless a mother explains the kid why the kid should pray, what to pray, when to pray, where to pray, how to pray, the kid will learn on their own. Recursive and iterative function. Now, if I take the CAT exam structure, as you know, CAT examination, this year, it is a 3-section paper. Quant will be the section number 3, which will have close to 34 questions. Quant is section number 3, which has 34 questions. If I see the last 3 years, trend of CAT papers from CAT 2017, CAT 2018, CAT 2019, the most important topics where the questions are coming repeated. If I see 21, 28, 32, 34, out of 34 questions, almost every year, CAT 2017, it was 1 day 2 slots, 2018, 1 day 2 slots, 2019, 1 day 2 slots. So almost 12 questions out of 34 questions are regularly coming from arithmetic. Arithmetic we are going to start post Independence Day. Only the enrolled students will get access to these classes. 12 out of 34, almost close to 30 to 35% of the questions, right, are only from arithmetic. Arithmetic I will take close to 48 to 60 hours of classes only for the enrolled students. Non-enrolled students can also join by WhatsApping this number 80500678991. 67891. We will discuss the entire arithmetic live batch. Most likely tomorrow I will release a video, right? And the next most important topic is 9 questions out of 34 questions, and it is close to 25 to 30% of the questions are regularly coming from algebra. Geometry, it is close to 7 to 34, close to 20%. 4 out of 34. 4 out of 34 is from modern maths and 2 out of 34 is from number system. So especially if a student is preparing for CAT examination, the areas which you should not neglect is arithmetic and algebra. Arithmetic and algebra. Arithmetic, 12 questions will come out of 34, right? That is the reason I will take a specialized live batch covering all the concepts of arithmetic in detail, starting most likely from August 16th. Entire August we will spend time on arithmetic live classes. Algebra, 9 questions out of 34. Sir, on what basis are you taking YouTube live classes? I will focus on algebra 9 questions. If you see here, entire maxima and minima per slot, there were CAT 2017, morning slot 2 questions came, afternoon slot 1 question came. Last year, morning slot 1 question came. Smaller topic, I took 3 sessions. Once you attend my latest YouTube live classes on maxima and minima, you will not get a single topic. Now see, why recursive and iterative function? Why we need to give 4 to 6 hours time for these functions? If you see, almost every year, not only from 2017, I am observing the papers from 2006 onwards. Every year, I have not seen any CAT paper without a question from a recursive and iterative function. If there is a CAT paper, there is definitely a question on functions. Now, if you see, last year morning slot, 3 questions came. Last year afternoon, 2 questions came. Last year, 2017, 3 questions came. Afternoon, 3 questions came. 2 questions in 2018 morning slot and evening slot 1 question. They're extremely important topic. Minimum 1 question to maximum 3 questions on every slot of CAT paper is coming from this topic. In functions, we are discussing a particular module, that is recursive and iterative function. Recursive and iterative function. We will take another class based on the domain and range and the inverse of a function. Then we will domain, range, inverse, even and odd function application, That will be the next subtopic in functions. Last will be the functions and graphs. Greatest integer function, least integer function, plotting the graphs, f of x, g of x, when two curves will intersect. That will be the last session. Functions is divided into three types. One is the type of function. In that one, recursive function, iterative function. How to find the domain of a function? Well, the domain of a function changes if you add it, if you subtract it, if you multiply it, if you divide it. What is f circle g? What is g circle f? Right? What is f circle g circle h? How to find out the range of a function, how to find the inverse of the function, how to check whether a function is an even number, even function or an odd function. What if two even functions are added? What if two odd functions are added? Last will be the graph part application. This is how you should prepare for functions. Today, through problem solving. Recursion. Recursion in simple language, it is nothing but repetition. It is nothing but repetition. Recursive function. Recursive function. If the function is used repeatedly to extract values, if a function is used repeatedly, the same function is used again and again to extract value, then the function is said to be a recursive function. A function which is used repeatedly to extract values. Most of the students who are from computer science or IT, right, or probably anybody who has done the coding in your first year will understand the definition of recursion, right, from a programming perspective. Then what is an iterative function? What is an iterative function? What is an iteration? Iterative function, right? A functional value will be same. A functional value will be same after some steps. A functional value will be same after some steps. If a functional value is same after some steps, iteration, the same value is getting repeated. One is a recursive function, another is an iterative function. All the problems, how a function is used repeatedly, after how many steps, the functional value will be same. Let us see these two concepts through problems. Each and every question, whatever I am discussing today, is most likely a previous year examination question. So if you attend the class, most likely recursive and iterative function previous year examination questions are also solved along with this class. I hope it is clear. Definition. Let us see the application part of this. First problem. There is a function. Now listen carefully, sir. F of m into n equivalent to f of m plus n. There is a function with two variables m and n. M and n are real numbers. F of 2 is given as 2005. Question is, find the value of f of 2 power 2006. F of 2 is 2005. F of 2 power 2006. Seems like a little intimidating question, but we will go very, very slowly. Now, if you see m equivalent to 2, n equivalent to 1. Why am I doing m equivalent to 2, n equivalent to 1? If I substitute m value 2, n value 1, f of 2 is clearly visible to me. So, f of 2 is nothing but f of 2 plus 1, which is nothing but 3. So next, I want 3. 3, how you will get m equivalent to 3, n equivalent to 1. It is nothing but f of 3 equivalent to 3 plus 1, 4. F of 3 equivalent to f of 4. I need 4 in the left hand side. M equivalent to 4. N equivalent to 1. F of 4 equivalent to f of 5. F of 4 equivalent to f of 5. Now, if you observe, you don't need to do, right? F of 2 value is nothing but f of 3. After f of 2, f of 3 value, f of 3 is coming back to f of 2. After f of 3, f of 4 is coming back to f of 3, f of 3 is coming back to f of 2. After f of 2, every next value is coming back to f of 2. f of 2, f of 3 is nothing but f of 2, f of 4 is nothing but f of 3, which is f of 2. That means every value is coming out and giving me a constant value, that is nothing but f of 2, that is nothing but f of 2. Iterative function, the functional value is repeating after some steps. Here the repetition or the recursion or the repetition of the value is happening after one step. It is nothing but a constant function. F of 2, f of 3, f of 4, f of 5, all are coming back to f of 2. So f of 2 is the answer for any real number after f of 2. f of 2 power 2006, before natural number it will be equal, that will be equivalent to before natural number, all will be equivalent to f of 2. Answer for this question is 2005. Very, very easy question. If you understand how to apply recursive and iterative function, these problems will be very, very easy. I hope the first problem is very easy. This is nothing but the classic case of a case where after one step it is getting repeated. Now let us see the second question. Second one, a lot of good questions are there. Second question, see the question. First, see the function that is given in the question, then it will be very easy. Just 1 minute, sir. Now read the question. If you read the question, f of x plus, if you read the question, f of x plus 3 by 2, the function could be anything, sir. F of x plus 3 by 2, it is nothing but f of x. By default, x is a real number, one functional value it is given. So he is saying if the iteration happens, how will be the iteration and what will be the functional representation of f of x. F of 5 is 8, f of 8 is how much? F of x plus 3 by 2 equivalent to f of x. Now let me first take the question. Question is f of 8. F of 8, 8 is nothing but 5 plus 3 by 2 plus 3 by 2. I hope the idea it is clear. Now if you observe here, if I take 5 plus 3 by 2 as y, this is nothing but f of y plus 3 by 2. This is nothing but f of y. X is replaced with y. So f of y plus 3 by 2 equivalent f of y. This is nothing but f of 5 plus 3 by 2. Again, wherever x is there, answer x plus 3 by 2 will result in x. So this is nothing but f of 5. F of 5 value is nothing but 8. F of 5 value is nothing but 8. Very easy question. It is similar to finding the unit digit repetition after some steps. Here we have to find out the function will get repeated after some steps. 5 plus 3 by 2 plus 3 by 2, this I call it as y. Y plus 3 by 2, it is y. Answer is f of 5 plus 3 by 2, which is 5. Let me see what is happening to f of 11. Then I will generalize this function. F of 11 is nothing but f of 11 plus 3 by 2 plus 3 by 2. Are you with me? 11 plus 3 by 2 plus 3 by 2. Now see here, if I take it as f of k, f of k plus 3 by 2 equivalent to f of k. This is nothing but f of 11 plus 3 by 2. F of x plus 3 by 2 is nothing but f of x, f of 11. F of 11 plus 3 by 2, f of 11. I hope the idea it is clear, right? This is nothing but 8 plus 3 by 2 plus 3 by 2, 6 by 2, it is 3. It is nothing but 8. It is nothing but 8. It is nothing but 8. Even if you do incorrect, it will come to your mind. If f of 11, if I am getting again 11, right? So f of 8, f of 8, f of 8, what is the value that you got? F of 5 is nothing but 8. Here also it is nothing but 8 plus 3 by 2. 8 plus f of 8. I hope it is clear. No, it is 5 only. F of 5 is given as 8. Here also f of 8 is nothing but equivalent f of 5. It is 8. That means f of 5 is 8. If I add 3, f of 8 is 8. If I add 3, f of 11 is also 8. That means what is the functional value? F of 5 plus 3k. It is nothing but f of 5. F of 5 is nothing but 8. F of 5 is nothing but 8. So that means repetition happens after 3 steps. So cyclicity for this function is 3 steps. After 3 steps it will be there. Just we will write it neatly so that there is no confusion. 1 minute, sir. So that this will not result in confusion. This is nothing but f of 5 plus 3 by 2 plus 3 by 2. This is k. 5 plus 3 by 2, it is f of 5, it is 8. 11, it is nothing but 8 plus 3 by 2 plus 3 by 2. 3 by 2 plus 3 by 2, 3. 8 plus 3, it is 11. So it is 8 plus 3 by 2, f of 8 is 8. Very, very important concept to know. F of x plus 3 by 2. It is nothing but f of x. So f of 5 is given as 8. F of 5 plus 3k. It is nothing but f of 5. F of 5, it is nothing but 8. Suppose for example, if the question is f of 38, let us check whether it is of this form. F of 5 plus 3 into 11. 3 11s are 33 plus 5. F of 38. F of 5 plus 3k, so it is equivalent to f of 5. F of 5, it is nothing but 8. So f of 5 plus 3k, it is nothing but 8. What will happen if it is other values? That kind of problems also we are discussing. Introductory problem, cyclicity of this function is 3. Cyclicity of this function is 3. After 3 steps, the value will remain same. After 3 steps, the value will remain same. I hope the idea, it is clear. No doubt, right, in this idea. F of 5 is 8. F of 5 plus 3k, it is 8. K is a natural number here. K is a natural number including a k equivalent to 0 for the initial value. Second problem. Third one. Now this is a simple management examination question. F of xy equivalent to f of x by y. Just to see the question, you will get the answer. 2000, already 500 it is given. So it is f of 500 into 4. So this is nothing but f of 500 into 4. So this is nothing but f of 500 by 4. F of 500 is nothing but 6. 6 by 4. Answer is nothing but 3 by 2. Very, very easy question. This kind of questions generally comes in SNAP exam or in some placement related examination. SNAP or in placement related examination. Very simple definition of substitution. Nothing I did. It is just substitution of x value 500, y value 4. We will not leave a single model from recursive and iterative function. Next question. Next. A1 equivalent to 1. A1 it is given as 1. So 3 into an plus 1 minus an. It is nothing but 1 by 3. It is nothing but 1. Let us keep 3 there only. So this is nothing but, if n value it is 1, 3 into a2 minus a1 equivalent to 1. If n value 2, a3 minus a2, it is again nothing but 1. If n value, if it is 3, a4 minus a3, it is nothing but 1. These nothing but 3 into, if n value, if it is 2004, 2005 minus 2004, it is nothing but 1. I hope you are all there with me. Before value will become, if n value 2003, a 2004 minus a 2003, it is nothing but 1. So every minus value will have a plus before. Every minus will have a plus before. Every minus will have a plus before. This is when n equivalent to 1. This is where n equivalent to 2. Last value, this is where n is equivalent to 2004. So if I add all the values, 3 into A 2005 minus A1 from n value 1 to 2004, 1111 it is added. So these are nothing but 2111 added 2004 times. So these are nothing but A 2005 minus A1 equivalent to 366 are 198, 3 8s are 24. A 2005 equivalent to A1 it is 1 plus 668. 1 plus 668, answer is 669. The same function I am using it repeatedly for n value 1, n value 2, n value 3, n value 4 and so on up to n value 2004. So this is a classical example of a recursive function. This is a classical example of where a function is being used repeatedly with consecutive values of n. N value 1, n value 2, n value 3, n value 4, n value 2004. N value 1 to 2004, 1, 1, 1, 1 added 2004. So it is 1 into 2004. Minus A2 is cancelled with plus A2. Minus A3 is cancelled with plus A3. Minus A 2004 is cancelled. What is remaining? It is all addition. So 3 can be taken common. A 2005 minus A1 is 1111 added 2000. 4 times 1 into 2004. Don't do any silly mistakes. Don't solve the problem in haste. Be slow, because definitely you will get the answer. And the most important topic, anyway, out of 34 questions are given in your CAT paper and 60 minutes time is given to you. 60 minutes time is given to you. Assume you spent 5 minutes in scanning the paper, searching for the easy questions and deciding to solve that questions. So you got close to 55 minutes left. Assume you attempted 27 questions. Each question you took close to 2 minutes. So you got about close to 80% accuracy. 80% accuracy. So almost you got 21 right and 6 wrong. 21 right and 6 wrong. So fairly you got 57 marks. 57 marks based on last few years of percentile. You are very, very close to just greater than 95 plus percentile. That means if you can increase your accuracy from 80% to 90%, you are almost there at the 99 plus percentile. The first thing is whether you know all the concepts from a particular topic. Then only you can score maximum number of questions right. You should know all the concepts, methods, tricks and shortcuts. Your familiarity with every possible question is of extreme importance for you to get maximum right, and that too in minimum time with consistent, self-motivated, directed practice. I hope it is clear. Recursive. Next one. F of x plus 1. Another example of a recursive function. F of x plus 1 minus f of x equivalent to 6x plus 8. Suppose if I substitute x equivalent to 1, f of 2 minus f of 1, it is nothing but 14, 6 plus 8. If x equivalent to 2, f of 3 minus f of 2, it is nothing but 12 plus 8, 20. If x equivalent to 3, f of 4 minus f of 3, it is nothing but 26. And this goes on up to, if x is, minus is preceded by a plus. If x is 2005, this is nothing but f of 2006 minus f of 2005. This is nothing but 6 into 2005. 1230 plus 8. 1238. 1230 plus 8. I hope it is clear. Now, if you see here, these are nothing but minus f of 2 plus f of 2, minus f of 3 plus f of 3. Everything will get cancelled. These remaining and these remaining. So, f of 2006 minus f of 1 equivalent to, it is nothing but 14 plus 20 plus 26 plus and so on up to 1238. 1238. These is nothing but, right, an AP series. So last term is 1238. First term is 14 plus n minus 1 into 6. These is nothing but 1224 equivalent to n minus 1 into 6. So n is nothing but 6 2s are 6 4s are, n is 205. So answer is nothing but sum is 205 by 2 into first term plus last term into first term plus last term. Don't show your mathematical intelligence here. Here you can play around with answer option. These is nothing but 205 into 1252 by 2. It is 626. Now see here, f of 1 is 16. Multiple ways you can solve. 6 5s are 30. 0 plus 6, 6. Answer unit digit should be 6. Answer unit digit should be 6. 6 5s are 30. 0 plus 6, 6. Another is, this is a multiple of 5. 5 3s are 15. Remainder 1. Answer when divided by 5, it should give a remainder 1. These nothing but, these divisible by 4. This gives a remainder 1. This gives a remainder 2. So answer should be, when divided by 4, it gives a remainder 2. You can check any of these divisibility rule or the unit digit logic. Kindly do not multiply and waste your time. Again I am repeating it. 5 6 are 30. 0. 0 plus 6, 6. Unit digit in the answer should be 6. 205 divisible by 5. 16 when divided by 5. Remainder 1. Answer. These divisible by 5. This gives a remainder 1. 5p plus 1. 16 divisible by 4. 5 when divided by 4. Remainder 1. 26 when divided by 4. Remainder 2. 1 2s are 2. 16 is divisible by 4. So it is 4k plus 2. 5p plus 1 or 4x plus 2 or 6. You can use any logic. 2 questions we did it. Now see here. Listen carefully, sir. This is a cat question. This is a cat question. Why you should? This is a cat question. 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 Next, all the questions whatever we are solving, all are previous year cat questions. All are previous year cat questions. Listen carefully. One by one we'll solve it. They are all easy questions. Right after the class, right? Kindly revise it. There is a function given. F of x is 1 by 2x. What is same function we have to use? Fn of x. It is nothing but f of n minus 1 of x. This is the function. We have to recursively use it for n values. N value, if I take 2, this is nothing but f square of x equivalent to f into f of x. F of x value is 1 by 2x. Wherever left hand side x is there, right hand side I should substitute that x. Wherever left hand side 1 by 2x is there, I need to substitute 1 by 2x there. It is nothing but x. So we will keep it aside. F square of x is nothing but x. Let us put n equivalent to 3. This is nothing but f3 of x equivalent to f of f square of x. F square of x is nothing but x. F of x is nothing but 1 by 2x. Now if you observe, just through observation, f1 of x is 1 by 2x. f3 of x is 1 by 2x. f5 of x will be 1 by 2x. f odd of x, it is nothing but 1 by 2x. f even of x, it is nothing but x. So if the power is even, then the right hand side is x. If the power is odd, then the right hand side is 1 by 2x. Question is, what is the question that was asked? f2008 of x. We will do even and odd. f2008 of x. Even. So answer is nothing but x. If the question is f313 of x. X is nothing but an odd value. Answer is nothing but 1 by 2x. This is a very, very important, right, function definition. F power odd of x is 1 by 2x. F power even of x is x. I hope the idea it is clear. Nothing I did, I used it recursively. N value 2, f of x, which is x. F of x here, if it is x here, this is x. Instead of x, it is 1 by 2x. So I substituted 1 by 2x. That is the root cause of a problem. Once you know it, then it will be easy. That means if this function, right, fn of x equivalent to fn minus 1 of x, recursive usage of this function with n value 2, n value 3, n value 4 and so on. I hope the idea it is clear. Answer for this question, it is nothing but x. Instead of x, you can give any value. This is nothing but f 2008 of 1 is 1. Right? You can put any value. Right? Next question. F of x equivalent to 3x square. Let us do it in a next slide. F of x equivalent to 3x square. What is the function that is given? Same function it is given. So, fn of x equivalent to f of fn minus 1 of x. Now, same function we will use it recursively for n value 2, n value 3, n value 4. N value 2. These is nothing but f square of x equivalent to f of x. F of x, what is the answer? 3x square. Wherever x is there, how much I need to substitute? 3x square. 3 into 3x square whole square. 3 square plus 3 power 3 into x power 4. I hope the idea is clear. Just I will keep it there and I will substitute the next value, n value 3. This is nothing but f3 of x equivalent to f of f square of x. F square of x, I got it as 3 cube into x power 4. So, wherever x is there, I need to substitute 3 cube into x power 4 whole square. 6 plus 1, 7. So, 3 power 7 into 4 2s are 8. Now, listen carefully. If I got 2 here, these are nothing but 2 square. If I got 3 here, these are nothing but 2 cube. These 1 less than this value. These 1 less than this value. So, without even doing, you can say f4 of x equivalent to x. 2 power 4, it is 16. So, these 1 less than, these are nothing but 3 power 15. Are you all with me? If f5 of x equivalent to, these are nothing but x power 32. These are nothing but 3 power 31 into x power 32. So, what will be the generic form? Once you understand the generic form, now see here, fn of x equivalent to, what will happen? X power 2 power n, 3 in power 2 power n minus 1. This is the generic form of fn of x. Recursive function, same function, this is the functional notation which is given. Same function, I am using it recursively for n2, for n3, for n4, for n5 and the process follows. If you observe the right hand side output, there is a pattern that is quite visible to me. If it is 2, I got 2 square and 1 less than 4, 3. If it is 3, I got 2 cube 8, it is 1 less than 8. Now, what is the answer which is, it is given? So, these are nothing but fn of x equivalent to x power 2 power n. It is just 1 less than 2 power n. It is clear? So, instead of x, let us put 3. It is 10. 3 f10 of 3. 3 power x is 3. 2 power 10. These are nothing but 2 power 10 minus 1, 1023. This is 3 power 1023 into 3 power 1024. This answer is 3 power 2047. We are not discussing iterative function. Iterative function is the functional value will be same after some steps. Recursive function, repeated usage of function. Repeated usage of function with multiple values of n. Repeated usage of function with multiple values of n. Both are CAT level questions. This is an extremely important topic for a student preparing for CAT examination. Recursive and iterative function. In case if you are enjoying the content, kindly click on the like button and share it with all the self-study learners who are preparing for CAT 2020. Idea it is clear? Next one. This question also we did it. Now F11, F23. These two are the classical examples of iterative function. Iterative function after some steps, the functional value will be same. After some steps, functional value will be same. How it is same? Let us see it. Functional value will be same. Now, just keep an eye on these functions, sir. I will tell you why I am asking you to keep an eye on this function. Just keep an eye, same function it is. Instead of f, it is given a. That's all. I will use the derivation that I derived from this. From right to the second problem. Original CAT question. One by one we will solve. First, let me write down the function. Fn equivalent to Fn minus 1 minus Fn minus 2. Fn minus 1 minus Fn minus 2. Now, see here. What is the value that is given? F1 is 1 and F2 is 3. F1 it is 1 and F2 it is 3. F1 1, F2 3. If I put n value 3, it is F3 equivalent to F2 minus F1. F2 minus F1. 3 minus 1, it is 2. If I put n value 4, it is F3 minus F2. 2 minus 3, which is minus 1. F4, it is nothing but F5, it is F4 minus F3. Minus 1 minus 2, it is minus 3. F6, it is nothing but F5 minus F4, which is minus 2. F7, it is nothing but F6 minus F5, which is nothing but 1. F8, which is F7 minus F6, which is nothing but 3. Just stop it here. Now see, what are all the values in serial order? 1, 3, 2. Minus 1, minus 3, minus 2. Again, if you see 1, 3, 2, minus 1, minus 3, minus 2. This is F1, F2, F3, F4, F5, F6. These F7. That means, what is the cyclicity of this function? After 6 steps. That means F1 plus 6k, it is nothing but F1. If it is 2, after 6 steps, again it will be back to 2. I hope it is clear. It is F3 plus 6k. It is nothing but F3. F4 plus 6k. It is nothing but F4. F5 plus 6k. It is nothing but F5. F6k. It is nothing but F6. Cyclicity of this function after 6 steps, the value is coming out to the initial value. F1 and F7 are same. Difference is 6. F2 and F8 are same. Difference is 6. F3 and F9 are same. Difference is 6. Cyclicity of this function, it is nothing but 6. Cyclicity of this function, it is nothing but 6. I hope the idea it is clear. Cyclicity of this function, it is nothing but 6. So after 6 steps, the value is coming out to be same. Let us go back. This is nothing but F2008. 2008 cyclicity, it is 6. 6 into 6 3s are 18. 6 3s are 4 plus 4. So these equivalent to F4 plus 6k. F4 plus 6k, it is nothing but F4. Cyclicity for this function, it is always 6. Remember, F4 plus 6k, it is F4. So F3, it is nothing but 3 minus 1, 2. F4, 2 minus 3 minus 1. Answer for this question is minus 1. If the function is of the form xn equivalent to xn minus 1 minus xn minus 2, xn minus 2, cyclicity, after 6 steps, the value will get repeated. It is not only the conclusion. If you see sum of 6 for any first 6, sum of first 6, 1 minus 1, 3 minus 3, 2 minus 2, that means that is used in the next question. An equivalent to an minus 1 minus an minus 2, n greater than or equivalent to 3. That means sum of the first 6 terms in the sequence, sum of the first 6 terms in the sequence, it is nothing but 0. Sum of first 6, a1 to a6, 0, a7 to a7, a8, a9, a10, a11, a12, that is also 0. Now we require sum of 2008 terms, sum we require. Sum of a 2008 terms, a1 to a6 out, right, like that till 2004. These nothing but a7 to a12, again 6 terms, a13 to a18. I hope it is clear. So till 2004 sum is 0. Sum of first 6 terms, it is 0. What is remaining? Sum of 2005, 2006, 2007 and 2008. 2005, 2006, 2007 and 2008. Now if you see here, 2004, it is nothing but a6. 2005, the first element, it is nothing but a1. A1 is 81.33, or you can write it as 2005 is a6 into 334 plus 1. Right? Now, or otherwise you can see it like this. 2006, which is a2 minus 19. 2007 is a3. A3 is nothing but a2 minus a1, which is minus 100.33. 2008 is 6 into 334 plus 4. If you want it neatly, I will write down here neatly. These an equivalent to an minus 1 minus an minus 2, n greater than or equivalent to 3. Sum of first 2008 terms, these nothing but a1 to a6. I am writing it neatly so that it will not be cluttered. It is a12, a8 to a18 and so on up to 2004. These nothing but 72, right? These a6, these a13. These nothing but a2009. These 2000, 2001, 2002, 3, 4, it is 1999. Now, if we require sum of 2008, these are all zeros. I require 2005, 2006, 2007 and 2008. 5, 6, 7, 8. Now see here, these are nothing but 2004, 6, 12, all the multiples of 6 are a6k, then 2005, it will come here. These are nothing but the first term, a1. 2006, it is the next term. These is the third term and it is the fourth term. These are nothing but a3 equivalent to a2 minus a1. These minus 19 minus 81.33 minus 100.33. A4 is a3 minus a2. So a3 value is minus 100.33, right? Minus, it is minus 81.33. 81.33. minus 19 minus 100.33 plus 81 minus 81.33. This and this will get cancelled. Answer is minus 119.33. I hope the idea it is clear. What is important to me is, in these two questions, there is an important concept. If the function is of this form, fn equivalent to fn minus 1 minus fn minus 2. If the function is of this form, there are two important conclusions, right? The first thing is cyclicity, it is 6 steps. Cyclicity, it is 6 steps. After 6 steps, it will come back to the initial value. Next conclusion is sum of the first 6 terms. Sum of the first 6 terms in the sequence, it is nothing but 0. Sum of the first 6 terms in the sequence, it is 0, and the cyclicity is 6 steps. This is the most repeated high frequency iterative function. So that is the reason I am stressing upon fn equivalent to fn minus 1 minus fn minus 2. I hope the idea it is clear. Slowly if you do, you will get the answer. This is a CAT question. This is also a CAT question. Again we will solve some conclusions. Now let us do the concept here. Now once you understand, it will be clear. What is the function? F of 1 plus f of 2 and so on up to f of n equivalent to n square f of n. Please don't substitute and find f of 1, f of 2. That is a mundane approach. Now if you see f of 1 plus f of 2, it is nothing but 2 square f of 2, which is 4 f of 2. These are nothing but f of 1 is 3 f of 2. These are nothing but f of 2 equivalent to f of 1 by 3. 3 can I write it as 1 plus 2? Yes or no? Right? Similarly, let us do for the first 3. F of 1 plus f of 2 plus f of 3. It is nothing but 9 f of 3. Listen carefully, sir. These are nothing but f of 1. F of 2, I will take it as f of 1 by 3 equivalent to 8 f of 3. I will do it here. 4 f of 1 by 3 equivalent to 8 f of 3. So f of 3 equivalent to f of 1 by 6. 6, it is nothing but 1 plus 2 plus 3. Now if you observe closely, instead of finding the values of f of 1, f of 2 and f of 3 till f of 9, f of 2 is f of 1 by 1 plus 2. F of 3 is f of 1 by 1 plus 2 plus 3. So if it is f of n, it is f of 1 by 1 plus 2 and so on up to n. Very, very important. F of n is nothing but f of 1 by 1 plus 2 and so on up to n. Do everything after f of 1, every other function, convert it into f of 1 form, then it will be very easy for you. So f n value 9, f of 9 is nothing but f of 1 by summation 9, 1 plus 2 and so on up to 9. F of 1 is 3600, summation 9 is 9 into 10 by 2, 45, which is nothing but 80. First one, answer is nothing but 80. Second one, what is the idea we got? F of n equivalent to f of 1 by 1 plus 2 and so on up to n. F of 1 value, it is given by 2005. N value here he gave it as 2005. So these are nothing but 1 plus 2 till 2005. Summation of first n natural numbers is n into n plus 1 by 2. 2005 into 2006 by 2. By 2, denominator by denominator, it comes in the numerator. Answer is 1 by 1003. Now another most important high frequency function that is repeated, right? There are certain functions which are repeating heavily. F of 1 to f of n. If it is n square f of n, then f of n is given by f of 1 by 1 plus 2 and so on up to n, which is summation n. Summation n. If you probably solve more number of problems, immediately it strikes, you can save a lot of time. Another variety of iterative function, as many varieties as possible. Another classical case of a recursive function, f of x plus f of x equivalent to x square minus 3x plus 5. f of 1 equivalent to 2. So first we will take x equivalent to 1. f of 1 plus f of 1 equivalent to 1 minus 3 plus 5. 6 minus 3, it is 3. What is f of 1 value? 2. 2 plus 1. f of 3 equivalent to 3. f of 3 equivalent to 3. Right? Whatever the output that you got, take it as an input. X equivalent to 3. These are nothing but f of 3 plus f of 3 equivalent to 3 square minus 3 into 3 plus 5. Answer is nothing but 5. f of 3 is 3. 3 plus 3, it is 6. So f of 6 value is 5. Then again take the output becomes the input. X is 6. f of 6 plus f of 6 equivalent to 6 square minus 3 into 6 plus 5. 36 minus 18. 18 plus 5. 23. f of 6 is 5. So f of 11 is 23. Again take these output as an input. X equivalent to 11. If I take x equivalent to 11, f of 11 plus f of 11 equivalent to 11 square minus 3 into 11 plus 5. f of 11 is 23. f of 11 is 23. 23 plus 11, f of 34. It is nothing but 121 minus 33 plus 5. It is nothing but 126 minus 33. I told you how you can do subtraction very easily. 126 minus 33. Decrease 3. And here decrease 3. 123 minus 30, which is 93. Answer for this question is 93. I hope it is clear. Make one number a multiple of 10. So what I did in this question, another variety of recursive and iterative function. Take the first value x equivalent to 1. Get the answer. Output becomes the input. Whatever output that you got, 3. Take it as an input. You got 6. Take it as an input. You got 11. Take it as an input. Output becomes the input. The best thing about Anil Nair classes course is I will do as many questions as possible so that your fear of looking at a new question in the mock paper, your fear, I wanted to kill the fear saying that no, Anil sir already taught this. He already discussed the technique for this. Familiarity is an extremely important thing. Otherwise, your confidence of sitting for a mock, probably, however external people motivate it, you will not be able to get it. I hope it is clear. Another model. This is one model. This is one model. Model 2, if I call it. This is model number 3. This is model number 4. This is model number 5. This is model number 6. This is model number 7. So totally 7 models we discussed till now. Now let us do another one. These, most of the teachers make these complicated. I will try to probably solve this question within 10 seconds. What you do is, these values are not, these are nothing but 1996. 1996. That means if I take these as k, these are nothing but 1 minus k. Yes or no? Right? This could 1 by 1997. This will be 1 minus 1996 by 1997. So I told you that k is a real number. K is a real number. So that means if it should also be satisfied, a function will satisfy all the values that domain of the variable is taking. If I take k value 0, this will become f of 0. This will become f of 1. Are you all with me? Similarly, if it is 2 by 1997, the previous value will be 1995 by 1997. Again, it is 1 minus k. So f of 0 plus f of 1. Let me do the first and the last. Put it in x. 4 power 0 by 4 power 0 plus 2 plus 4 power 1 by 4 power 1 plus 2. These are nothing but 1 by 3 plus 2 by 3, which is nothing but 1. First and last, first function and the last function, sum is coming out to be 1. Like that, second function and second last function, sum comes out to be 1. Total 1996 are there. Every doublet, first and last, second and second last, all that will add up to 1. So half of them it will be there. 1996 by 2. Answer is nothing but 998. I hope the idea it is clear. First and last, second and second last, third and third last. You don't need to do it. Just what is he trying to do is he is trying to create a fear by giving these odd fractional values. 1 by 1997, if I take it as p, last value is nothing but 1 minus p. So you can also do it by doing 4 power b by 4 power p plus 2 and put 4 power 1 minus p by 4 power 1 minus p plus 2. Do it, you will get the same answer. Unnecessarily do not waste too much of time. Idea it is clear. Next one, another way of solving the recursive and iterative function using answer options. We have still not used answer options. We can use answer options to solve. How to use answer options? Let us see. an minus an plus 1 minus 3an plus 2, it is nothing but 4n. This is the question. I will write it again. an plus 1 minus 3an plus 2, it is nothing but 4n. n is greater than or equivalent to 1. Let me put n value 1. a2 minus 3a1 plus 2, it is nothing but 4. a2 minus 1, it is nothing but 4. a2, it is nothing but 5. All the answers are of the form 3 power something plus or minus. 5 can be written as 3 square minus 2 into 2. 9 minus 4 is 5. From where this idea of 3 power something we got? Just looking at the answer options. Now see here. Let us do for one more value. N equivalent to 2. This will become A3 minus 3A2 plus 2. It is 4 2s are 8. A2 it is nothing but 5. Minus 15 plus 2 minus 13 equivalent to 8. A3 it is 21. 21 it is again 3 cube minus 3 into 2. 27 minus 6 is 21. 9 minus 4 it is 5. If you observe, A2 is 3 square minus 2 into something. A3 is 3 cube minus 3 into something. An will become 3 power n. 3 power n minus n into 2. Are you all with me? Right? 3 square minus 2 into 2. 3 cube minus 3 into 2. A power 4 is 3 power 4 minus 4 into 2. So, A100 will be 3 power 100 minus 100 into 2, which is 3 power 100 minus 200. 3 power 100 minus 200. I hope the idea it is clear. 3 power 100 minus 200. These just nothing but, right, simplifying to the smaller values, simplifying the question. If I simplify the question, I will get the pattern for this question. I hope this idea it is clear. These nothing but model number 8. Model number 8. Model number 7. All the variety of the models in a particular topic you should be good. These model number 6. These model number 5. The more and more models you discuss, your fear will not be there. These model number 4. These model number 3. These model number 2. And this is model number 1. Model number, these are all model number ones. Various models we solved in this class. I hope you enjoyed the recursive and iterative function.